chemistry teacher from St. Paul's Anglican Private Secondary School. So you're welcome. So last week we started looking at titration. We defined what titration is. We defined what endpoint is, and we went as far as looking at the types of what titration. But since it indicates what? Acid-base titration. Now the way for neutralization of titration. So that's what we're going to discuss today. So we're going to discuss about precipitation titration and the other types we discussed last week. So our focus is on acid-base titration. So we're going to talk about a reaction between acid and the base. We call it what? Neutralization reaction. Neutralization reaction. So which means what? Salt and what? Water. But let's say that we're given acid as well as the base. We want to look at the end point of what our reaction. Now we want to tell you the end point of our what? So we talked about what the different indicators that we can use for acid-base titration. And the common one that we use is what? Indicator. So in our experiment today, we're going to use what? Another indicator, acid as well as base, to demonstrate the acid-base titration itself. Titration today, we're going to use sodium hydroxide as well as what? Hydrochloric acid. Mind you, last year in 2024, with the handout that I've given you, they gave the students HCl with what? Non-concentration. Meaning to say, we were supposed to find out the concentration of sodium hydroxide. So, but this time around, in the experiment that we're going to do today, the known concentration is only for sodium hydroxide. So our concentration is 0.1 more. And again, we want to find the concentration of HCl. So as we do the experiment, we're going to verify, we're going to do and follow all the procedures. So let's hear what the procedure is saying. So the procedure is saying provided for 0.1 molar sodium hydroxide, 0.1 molar sodium hydroxide solution. You're also given hydrochloric acid of unknown concentration. So you see HCl, we haven't indicated any what? We haven't indicated the concentration here. And again, we also provided what? Phenolphthalein indicator in a dropper bottle. So this is what? Phenolphthalein indicator in a dropper bottle. You've been provided with distilled water in a wash bottle. You're also provided with what? A blade. So this is our capsule, a funnel, a white tile, so this is our tile. So let's now go straight to the practice. So I'll start with what? How do we degrade on the transfer? So the next thing is just another what? Follow the procedure. Put 15 cubic centimeters of sodium hydroxide solution into the conical flask. We need our measures. This is what I'm going to do. So make sure you're accurate and you're precise. So as you can see, this is our 15 cubic centimeter sodium hydroxide. So fill the burette with the brain hydrochloric acid solution. So we're going to fill our again, make sure that the tap is on. we are going to use hydrochloric indicator and 3 drops of hydrochloric indicator as well. Sodium hydroxide. So I'm going to add 1, 2, then 3. Oh. So as you can see, the colors change what? The colors. So now the next step is the volume of the acid. So you see that the volume of the acid now is on what? It was on 50 tests, but now it's on what? 45. In other words, it's what? It's a volumetric analysis. We want to know, for us to find out the concentration of the acid, we need to know the actual volume of what? The HCl used. For this time, we're going to do it 2 lines. So we did our first line, we're also going to do our second line. So So at first, it was what? 50, our initial volume is 50. After we did our first our first titration, the volume is what? 45. And for our second one, the initial is 45 and the next 2, 3, 4, 4. So initially, we will cover first one, second. So initial and the final. So our initial was the volume was 50. After titration, we reached 45, and the next one it was 45. So this is our initial. 55 was our initial. Then afterwards, after graduating by the acid, the concentration of the volume reached what? The 40. So we find the volume of the HCl used. So it's just a matter of subtracting 50, 45, 40, 50, which is giving us what? 5. And again here we have what? 5. What we call cubic. So we have found the volume of the acid used in our experiment. So then our next step is to do it is to find the average volume used. Average volume used. So average, you know, we have what? 5 plus 5. Right, you have to end there. You have to so giving us 10 cubic centimeters. And that's what 5 cubic. So the volume used for the acid is what? 5 cubic centimeters. But sometimes the volume might vary. Maybe here of us will find what is 5. Sometimes we can find here 6 or maybe sometimes 4. So whenever we make our experiments, they are errors. So that's why we're supposed to do what? The average. In other words, we're supposed to find the average volume used with the acid. So now let's try and work out the concentration of the acid, which is our HCl used in our experiment. So remember that we've been given what? The concentration of what? Sodium hydroxide. Our base, we know its concentration, which is 0.1 molar. And the volume that we've been using all 2 lines is 50 cubic what? Centimeters. While for HCl, as said earlier, we don't know its concentration. The volume used in all two lines, and after doing the average, we found the cubic centimeters. So using this data, we can be able to calculate the concentration of the acid. So we are going to use what the titration formula. VA over NA is equal to CB, VB over AB. So just a reminder, CA indicates concentration of the acid used in that particular titration reaction, while VA is the volume of the acid used to neutralize the what? The base. While NA, we're talking about the number of moles of the acid in the balanced chemical equation. CB, concentration of the base, VB, volume of the base used, as well as NB, the number of moles of what the. So most students, I think, you're formed of just what CA, VA is equal to CB, VB, is equal to NA, NB. So most of the requirements are using what NA, just say CA, VA, CB, and what VB. But it's very crucial to indicate what the number of moles of the acid used in that particular titration reaction. In other words, in the balance of chemical equation, as well as the number of moles of base in the balance chemical equation. So what we're going to do is then, what is remaining is what? Is salt. So, what is the salt that produces in this particular reaction? We have sodium hydroxide and HCl. Sodium chloride, which is what? Aqueous. Because as we can see here, it's really aqueous. It's not in solid what? So it's aqueous. So we have our salt as well as water. So we need to make sure that our equation is balanced. So let's see, how many sodium hydroxide do we have in the reactant site? We only have one. In the product site, we have what? One. Now of oxygen, one, and also here one. Hydrogen, we have one, two in the reactant site. In the product site, we have what? Two as well. Now chlorine, we have what? One, and this is what? One. So in this case, it is what? It is balanced. So Na is equal to 1. So the number of moles just reflects the coefficient, which is what A. So the number of moles of the acid, which is HCl, will not be so definitely we get 1. So definitely it's 1. So the hydroxide again is what? It's 1. So NB is equal to 1. So it's a 1-to-1 addition. But to be safe, each and every time make sure you give the number of moles, because this means you're using sulfuric acid. The balance equation not what 1-to-1 mentioned for the number of moles of what? And the acid as well as the base. So make sure each and every time, or in our next lesson, maybe we'll see how we deal with acid and others. The reaction where we will find my 1-to-1 ratio. But now let's focus on this one. So our formula CA, VA, NA is equal to CB, VB, AB. So we know the volume of the acid, the number of moles. The number of moles of what acid we in the balance in the equation 1. We know it is 1 x 5. The concentration of the base 0.1 mole. The volume of the base is 15 cubic centimeters. As well as the number of moles is 1 again. So definitely what we're required to do is just to make the subject of the formula. So we need to make a Ca, which is the concentration of the acid, the subject of the formula. So what do we the subject of the formula? We're going to make that of Ca is equal to CBVB over NB times VA. So you can check, but started developing. That's where we're in at. So let's see. We have the concentration of the base as 0.1 mole. 0.1 mole. For you, this 50 cubic centimeters. And the number of moles part, sodium, not sodium, we start for the HCl because it's a rock. So HCl, number of moles part, acid HCl is what is 1. So 1 mole. Over the number of moles of base, which is also in hydroxide, is 1 mole. And the volume of the acid used, I think we found it's 5. So now let's see the concentration of the acid. What is the concentration of the acid? So just another using the calculator, punching in the light digits. So we have 0.1 multiplied by 15 multiplied by 1, which is giving us 1.5. Divide by 1 more times 5 is definitely 5. Yeah? So let's go with 5K. So it says that what more times of what more K centimeter what K centimeter. Then you have what those units. So you have what 1 more. Make sure it's a capital M. So 1.5 more divided by what 5. Meaning to say that the concentration of the acid used in our titration experiment is 0.3 more. So that's how we work out the titration. Titration, acid-base titration question if we do the practical session. Before you die.